Hello everybody, Mr. Kerrigan here. We're going to start our unit on conic sections today and go through our first section of circles. And we're basically just going to focus today on graphing circles and changing from one form to another. Before we do that, just conic sections in general, by definition, are the intersection of a plane and a cone. Okay, so what that means is if you look down here at these four pictures, this one, this one, this one, and this one, if I take a cone and I just take any old plane, think of it like a piece of paper, and I slice straight through this first cone here, straight across through, this slice that it makes is going to be the shape of a circle. Okay, if I do the same thing for the second one, but I slice through kind of on a little bit of an angle, notice that it's not completely circular, it's more of an elliptical shape here. So that second conic section that is created from the intersection there is going to be an ellipse. If I do the same thing for number 3, but notice that here the slice does not go through both sides of the cone, it just goes through the one side, and what is left there is that parabolic shape. So my third type of conic section is a parabola. And then last, if I just cut straight down vertically through just one side of that cone, it's going to give me a parabola up here and a parabola down there. And combine both of them together is a hyperbola. So the four types of conic sections that we have are circles, ellipses, parabolas, and hyperbolas. We talked a little about parabolas already within our quadratics unit. Now we're going to get in a little bit more with parabolas that are in functions that open side to side in a couple days. But we start today with circles. Many of you remember circles back from geometry, maybe even a little before that. By definition, what a circle is the set of all points at a given distance called the radius from a given fixed point called the center. Okay. In order to graph circles, what we need, and I wrote up here kind of starred, is this equation right here is the main equation that we will need in order to graph a circle. This x minus h quantity squared minus y, or I'm sorry, x minus h quantity squared plus y minus k quantity squared equals r squared. That is what we call the standard equation of a circle with center at h comma k and radius of r. Okay, now notice that h comma k has come up in functions that we have seen in the past, and it's no different here. Back when we had our quadratic functions, we had y equals a times x minus h squared plus k, where h and k was our vertex. Here, h and k will represent what the center is of this particular circle. So, in our first example here, x minus 3 quantity squared plus y plus 1 quantity squared equals 16. In order to graph that, the two in order to graph a circle are simply just the center and the radius. In this case, x minus 3 squared and y plus 1 squared, my center is going to be at positive 3 comma negative 1. Now remember, in the equation, it's x minus h. So here, x minus positive 3 is what's written there. That's why my center is at positive 3. And the same thing for the y value. This is y minus a negative 1 would give me a value of y plus 1 inside the parentheses there. So my center is at 3 comma negative 1. Remember on the right side in the equation, it's r squared. So 16 is not my radius. It's actually going to be whatever the square root of that number on the right-hand side is. So my radius here is 4. Now, in order to graph, it's very, very simple once you have your center and your radius. All I'm going to do is plot my center first, so 3 comma negative 1, which is right down here. And then from that center point, whatever my radius is, I'm going to go that many units from the center to the right, to the left, up, and down from the center. So at 3 comma negative 1, I'm going to add 1, 2, 3, 4 units to the right, I'm going to go back to my center and go 1, 2, 3, 4 units to the left. From the center, I'm going to go 1, 2, 3 units up. I'm sorry, 4 units up. And then I'm going to go 1, 2, 3, 4 units down. And then simply just connect those dots. I'm awful at drawing. And that's what my circle looks like. Now, in terms of what information you're going to have to give next to your drawing, think back to when we had quadratics, you had to list out what the vertex was and the axis of symmetry and the intercepts and this, that, and the other. Here, what you're going to need to list out for me is going to be what the center is, what the radius is, and what those 4 points that you just created by going up, down, left, and right. Okay. Now, the easiest way to do this is whatever the radius is, that you can just count, and look at those 4 points, and from 0, 0, say, okay, this one I want units to the right and down 1. Or what you can do is from the center, just add and subtract whatever the radius is to the x value and then also to the y value of your center. So in doing that, if I just start with the x values, if I add 4 to that, I'm going to get 7, -1, which is this point right here. If I subtracted 4 units from my x value, I'm going to get -1, -1, which was this point right here. And then if I do the same thing with my y values, if I add 4 to -1, I'm going to get 3, 3. And then if I just another quick example for that, I'll go through this quick. Here, that HK form, my center that I'm given, in this case is going to be -2, 0. Notice here, x plus 2, that's x minus a -2. Here, just y squared, that's y minus 0 squared. My radius is the square root of this number on the right-hand side, which is 5. And then I go ahead and plot all of that. -2, 0 is right here. I go to the right 5 units, 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5. Up, 1, 2, 3, 4, 5. And down, 1, 2, 3, 4, and 5. That was worse than the last one. Not very good at drawing. Here, those points on the circle are going to be at 3, 0, -7, 0, -2, 5, -2, -5. So as you can see with these 2 examples, it's very, very, very easy if it's given to you in that already standard, HK form. Where it gets a little more challenging is if I were to give you the equations not in that standard form. If I gave it to you in a different form, and you would have to convert it over to standard form first, right? The only other form that you can create is this one right here. X squared plus y squared plus ax plus by plus c equals 0. What we call this is the general conic form. Okay, each of the conic sections, there's going to be a general conic form to it, and also that standard form to it. The standard form is what you want in order to graph, right? So the first thing we're going to need to do is be able to take a equation in general conic form like this one here and convert it over to that HK or standard form. In order to do that, the first thing you want to do, so step 1, I'm going to all together. So I'm going to take that x squared and 10x, and I'm going to put them right next to each other. And I'm going to put all the y's together also. So I have x squared plus 10x, and then I have my y squared minus 4. I'm also going to move that positive 21 over to the other side to a negative 21. So now I have a group of x values and I have a group of y values that are next to each other. Next, what I'm going to do, I'm going to write CS for complete the square. I'm going to complete the square twice. I'm going to do it once for the x values, and I'm going to do it again for the y values to get x minus something quantity squared and y minus something quantity squared in order to get it in that standard form. So what I'm going to do here, remember with complete the square, you take your b value, which in this case is 10, divide it by 2, which is positive 5. Square that is 25. And I'm going to add that to this side of the equal sign. And then I also have to add it over to that side of the equal sign. I'm going to do the same exact thing to the y's. I'm going to take y squared, minus 4y, and then divide negative 4 by 2 is negative 2. Squared is 4, and I'm going to add 4 here and also there. Okay? So now on the left side, I have two perfect squares. This is going to be x plus 5 quantity squared. And this is y minus 2 quantity squared. And on the right side, just clean that up. Negative 21 plus 25 is 4. Plus 4 is going to be 8. So here is that equation in the standard center, negative 5 comma 2. Radius, now 8 isn't a perfect square, but that's okay. We can still find the square root of that, which is going to give me 2 root 2. All right? And then I would be able to do anything I wanted with that. I could then go ahead and graph that by just plotting negative 5 comma 2 and add, subtract 2 root 2, both to the x values and the y values. All right? I'm going to keep these two for you to do on your own if you wanted to as practice. I'm going to pop down here to this last portion since we only have a couple minutes here. The last thing that I'm going to ask you to do, I can give you the equation and you be able to graph it for me. But also, if I give you a graph, you should be able to tell me what the equation of that particular circle is. It's very, very, very simple to do. Remember, the equation, you have x minus h squared plus y minus k squared equals r squared. Well, as long as you know where your center is and what the radius is, you're simply just plugging that straight in for h and k, and that is it. So in this case, notice that my center is at negative 1, 2, 3, negative 4, comma 2. And your radius from there, I'm going 1, 2, 3 units to the right, 1, 2, 3 units up, 3 units to the left, and 3 units down. So my radius is just 3. So the equation here in that standard form is simply going to be x plus 4 quantity squared plus y minus 2 quantity squared equals 9. And that's it. Very, very simple. Now, I could have asked you for it in the standard form or that general conic form. If I ever ask it in general conic form, you still start by getting the equation into that standard form. And then all you would have to do plus 4 equals 9, and then group everything together. Plus y squared plus 8x minus 4y, and then take the 16 and the 4 and subtract it over to the other side. That's going to be 20. Move that over to the other side. I'm going to get negative 11. So I'll answer here. You want your x squared, your y squared, your x term, your y term, so minus 4y, and then that 11 will come over here to 0. Okay? So that's that. We don't have to focus as much about going from form to form, but just being able to graph, and then also looking at a graph and finding the equation is the gist of this, this video. Okay? All right, everybody.